I'll be starting momentarily. I forgot to be starting soon. Hello.
Hello.
Hi.
Hi.
So today, I want to try to work through these hazards. Thinking. So last time I was walking through some instruction sequences through here, but I feel like this was splitting them off like this is gonna be really nasty. When I think I'm gonna go into Google Docs and then just make a new sheet on the spreadsheet and just make a list of like 30 instructions and then like iterate through it to see how it need to operate.
Oh yeah, you were doing the state machine, right?
Yeah, I'm trying to find the because I feel like this is gonna be much cleaner if every register has its own just mini little tiny state machine, versus those tracking all those bits and stuff like that. Because they're only ever gonna be like, you may have like a hybrid state where you need to be written and read, but that can just be like some new state. It could just be like a fifth state. I feel like that would actually be somewhat cleaner. Okay, so let's just start making a series of instructions. Load R1, R3, add I'm gonna use the actual assembly. No, I'm not. No need to use anything specific. Add R1, R4. Sub R. I'm pretty much just gonna only use adds and subs because there's no real point. They're just adds and loads are the only real thing that needs to. Actually, I'm gonna use these in the order that I'm using the registers. It's easier to track when it's the order that they're first used. And then let's try go a load. Load R3, R7. No, R6, that's fine. Add R7, R3. Add R8, R3. I'm doing some weird instructions I know probably will never happen in this order. They probably won't ever, but it gets the hazards across.
Oh yeah, throw up your screen share when you get a minute.
Okay. I'm pulling the block diagram off to another screen so I can actually see it. So this, A operand, B operand, do. this would be, so this would be ink mark R1 pending write ink pending read. Then this, oh yeah,
I'm on my own, broken alone. I feel the rain crashing down all around this empty town. I'm searching for the lost and found, but you don't care, you're unaware. Keep moving like the scars aren't even
this is ran ahead.
It's in the air like a blazing flare.
Yeah.
Cause the flames will burn us up.
Mark R3 soiled ink pending read. Oh my god, I'm getting way too many emails at this point. I need to like cancel signing up for updates on different like boards and shit. Okay.
Like shadows in the atmosphere, charting the stratosphere. I prayed for you and kept you near in hopes you'd chase away my fears. I'm on my
Okay.
own. You made it so.
I need to close my window.
Now I'm chasing nightmares. I used to run
Actually, it's not coming through on the mic, surprisingly.
Oh. You hear anything?
My apartment complex is doing maintenance and stuff today, so they're going through. There's like a bunch of like lawn machines and different things. They do like their big old like pre-summer push or whatever. So like there's just loud machines outside.
It's been me. I've been doing yard work for the last 2 weeks, trying to get everything ready for summer. Yeah.
Okay. Let's see, what cycles do I want this load to come back on? See, what's the actual pipeline's load latency? See, we have. This would be one cycle. This would be one cycle additional latency going into. It'd store into there, and they would go into here for for 2 cycles for the memory, and then 3 cycles there. So it's a 3 cycle penalty. Okay. So if this is a if this was a that would be where I normally write back. So then 1 cycle penalty, 2 cycle penalty, 3 cycle penalty. Load writes. This would be normal penalty, 1, 2, 3. Load writes. Is that another instruction? R9, R1, R9. This would be. This would stall. You meant the world to me.
there's a distance between us. It's getting hard to reach out. Haven't seen you in seasons, but all I hear is your voice. I know my limits, you can break me down, but I'll stay till the finish line. And I've been counting minutes for quite some time now, just to see you again.
Okay, so this is stall.
And I've been counting days to
The load right's there, so then that means
again, see you again. Been finding ways to get away, to see you again, see you again. See you again.
okay. This is fetch path, run ahead. Oh my god, I really wish I could like animate this through the fucking pipeline. That'd be so much easier.
We're almost there.
Right?
Hope we're not too broken.
Yeah, I know, it's so hard to do this in your head.
And I've been
So when we stalled there,
to get away, to see you again, see you again. Been fighting
these instructions would be issued.
to get away, to see you again.
And these two would process through. Actually, I need to then move this down one more, because this needs to go there. Okay. The status. Okay. Okay, so this is kind of where how this would operate. And then when this executes, this R1 would oh wait, no, this needs to go one additional cycle down because that load will need to have written. Here R130. See, this is why I'm glad I did this, because right now when this R1 drops dirty, the to be written flag would still be high until R1 writes. but I feel like we need to demote. So I think instead of marking pending right, we need to promote to pending right. I'm going to remove the R1 because it's not really needed. Okay, so you clear R1 dirty, and then, or demote R1 to dirty. Yeah, because because R1 is now in the run ahead queue. Oh, hold on, no, wait. This needs to demote to soiled. Demote to soiled, because dirty so. It's soiled right now. If we make it dirty, it's not going to be able to DQ from here. And this demote to clean. Yeah, because now it's going to be soiled to clean. Oh yeah, this is not increment that. This decrements pending read. So when this gets up to the front, this will be on the front of the reading queue, and because this is the front, we can ignore any other pending reads. Because this stalled, because there's stuff in front of the run ahead queue that can run. It runs first. So now this sub can run immediately after that. Okay, so I think we need to do something with this. Registers need to be able to be marked. Registers need to be marked. So if an operand was dirty simply because of forwarding, so like right now this sub, there's a pending read on at R3. Wait, no, so I'd be able to run that. Do I care about that? Because right now R3 is to be read, and since it's R3 up here, since it's the head of the queue, it should always be fine. So since that means there would be no pending like to be written to R3 or whatever, it'd be the head of the queue, and this installed, I can just let that propagate. Okay. Remote to clean. And this install, that goes normal. Normal. I'm gonna say exception rather than status. Status, we're gonna leave these empty. This would be mark. Okay, so what I think I need to do is, this is my gut instinct right now, is okay, so if we have this, we have a flow chart of states. We have clean, we have to be read, counter, pending write. I like pending rather than to be. Pending soiled. So what we need, what for a given register, we have these. Oh yeah, we also have dirty.
Dirty, yeah.
Okay, so a register can go from clean to dirty. It can go from dirty to write pending. It can go from write pending to soiled, and it can also go from write pending to dirty. Then from soiled, you can go clean, or you can also go from clean to soiled.
Soiled just means it was recently dirty.
So soiled, what soiled is going to represent is soiled represents if you're to be read. So in this use case that we have right here, in this case, since R3, since this instruction is in the run ahead queue, and you can't run this sub because it's going to corrupt R3. So this is pending in the run ahead queue. So R3 needs, the state needs to be preserved. So since R3, since you're pushing this instruction to the run ahead queue, not because you're waiting for a load to go to R3, is because you're waiting for something to read R3 from the run ahead queue.
Okay.
So soiled is a pending read, an instruction that has a soiled register is a register that has an instruction that with a pending read in the run ahead queue. So let's label what each of these can happen. This is writing, multi-cycle write operation. Oh yeah, they also need, you can go, essentially you can go, this is my biggest thing, you can literally go any way you want around this. Okay, right cycle. Yeah, I need more. This needs to be more space. Okay. And then okay, so if you're in a pending write situation, okay, so let's go through this, the instruction life cycle. Oh my god, I don't have enough screen space to do this. I wish I could stream like 2 screens at the same time. So I'm looking at that spreadsheet I was just filling out before. So R1 goes soiled because there was a pending read. So even though there was a write, So looking at it here, R1's dirty, and then it's promoted to pending right, and then here during the stall cycle, it's demoted to soiled. I'm trying to think of, is there any time that it could go, it can go from to be written to dirty in the same cycle? I don't think so, because I think if you I know I'm quiet right now, I'm just thinking.
We're good.
So we go through these instructions, and when R1 clears, I don't think it can go dirty, because it can't immediately go down to dirty, because you're not issuing a multi-cycle right. The most you could do is demote to soiled if you have a pending read. So what I need to do is, this actually needs to have a decision on it. Let me, pending read. Yes. And then this would be no. Actually, this would probably be cleaner if I did it like this. Yes. No. Okay, so we have this situation here. There's a pending read. Oh, pending right read. This needs to go not dirty, but to clean. Okay, so now if you're soiled, you can go pending right. So if you get a multi-cycle right back, you'll decide whether or not you're going to pending read, yes or no. Either you go to clean or you go to soiled. Now, if you're soiled, if you get an issued instruction, issue writing instruction. Okay, so if you issue any writing instruction whatsoever, and it's soiled, you go to pending read, pending write. I really liked it. That we're finally making good progress. I feel like I'm happy with this. This is any multi-cycle. I don't know why I deleted this. Multi-cycle, right? Issue. I don't like that double use of the word. The multi-cycle issue, multi-cycle write back. And this should be the same condition. So regardless of what happens, you just, if you're issuing an instruction to run ahead, Okay, so then I think the only other transition we have is to here. Which would be this condition. Okay, I think this covers everything.
Seems a lot simpler now, doesn't it?
Yeah. So yeah, and now what I think I'm gonna do now, I'm gonna run through that same. I'm gonna delete all the notes for that instructions that list of instructions we just put. Either I'll just copy those list of instructions off. No, I'll just delete it. And then I will take that list of instructions and one second. Okay, I have just a list of instructions. I want to go through that list of instructions using this state machine and seeing if this works, because I feel like this will work, because this to be read is just a counter. Like, it is just a counter that informs this is just an informative counter.
I think this is a good chart now because I can actually understand what the fuck you were talking about last time.
Yeah, I really like this, because this should protect me against all this stuff. Because if you ever try to issue a write instruction on top of a pending write, you just stall. If an instruction, so I'm gonna play through this. So if an instruction is dirty, it can be, and it's pending read, right? And you try to write back to it. If it's dirty and you try to write, then it goes to pending write. You can't go from dirty to soiled. You can't directly go from dirty to soiled, because by the nature of the pipeline, you'd have to clear. If you wanted to go from dirty to soiled, you'd have to clear your dirty bit first. Oh wait, how do I get to? Okay, yeah, getting to soiled. You can go from clean to soiled if pending. Oh, okay, I forgot a transition.
Is there a pending read after dirty?
No, there's a pending read after clean.
Oh.
I'll figure out where to place this next. Oh no. So clean can go to soiled. So if you have no status at all, and you're just like a statusless instruction, or status, if you're completely clean, but then an instruction that's reading from you gets pushed to the run ahead queue, then you get marked soiled. Because this is like the tangential to dirty that we mentioned. How like you're not really dirty because you're not being marked dirty because of a multi-cycle write. So there's no multi-cycle hazards. The hazard that you're trying to avoid is something that's pending in front of you in the run ahead queue. So by nature of being soiled, by the time you're at the front of the run ahead queue, whatever hazard that marked you soiled will have already been cleared by the nature of you being at the front of the run ahead queue.
Right. Makes sense.
Okay, I'm very, very happy with this, actually. Play this good pausing break for me to stretch real quick. I just gotta reheat some tea. That's pretty much it.
Are you using your stand-up desk?
Not right now. I'm sitting at it.
Oh, yeah. Wondering. Thinking about setting mine up again.
The next place I move, I'm hoping to have like a full office room set up that's separate from my gaming stuff, so I can actually have like. Because right now I kind of like I have it down because gaming standing up is not as fun for me. Like I can, but I don't know.
I know what you mean.
So like every time if I work on it raised up, a few hours later my girlfriend's here, so I lower it back down. It's just a pain in the ass. It would be not as bad if I wasn't on carpet, but because I'm on carpet, my chair doesn't roll back. Like I can't just like push it out of the way. I have to like pick it up and move shit. So if I had wood floors in this room, it'd be 100 times easier for me to go back and forth. I also just need more space because there's 2 computers set up here, me and my girlfriend's, but I need the second desk was supposed to be me for work stuff. So I just have 2 bins stacked upside down as this little temporary side table. I need lots of desk space for work. But yeah, I'm gonna get up and just like do a lap around the apartment, pretty much stretch real quick.
Say it like that. If I hate you, then find someone new. Baby, but you know I never will. No, so I choke you down just like a pill. Oh yeah. You like a fill you like a pill to get my fill. No, do me in the worst way. Don't let me sleep, never say you're sorry. Oh, maybe I'll leave, baby, but you know I never will. No, so I choke you down just like a pill. You like a get my fill. Oh, you make me wanna talk back to you. Say it like that. If I hate you, then find someone new. Baby, but you know I never will. No, so I choke you down just like a pill. but you know I never will. No, so I choke you down just like a pill. Oh yeah, take you like a pill. Get my fill.
I was looking into darkness for something to hold on. Found you when you were so broken, and I felt something was wrong. I think I'm in love, 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 I'm in love with you. I'm in love with you. Ooh, I'm in love with you. I think I'm in love, 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 I'm in love with you. I'm in love with you.
When the lights go down, I've seen hell in you, but you don't care, no, you don't care, no. You just rather watch me fall from a golden mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it all. You said you wanted to fall into oblivion. Forget about the world we're living in. Fall into oblivion.
Hello, everybody.
Welcome back.
So, okay, so with this state machine, why did I even I wanted to look at the block diagram. So if we're reading the states out here, and then we're the simple thing. This all it does here is say whether or not the instruction's going to the run ahead queue, and just promotes it off to the side and allows for the forwarding and immediate stuff to take place. So with that being said, I think I actually need to pull this up a stage, because in order for this state machine to work, because the states get updated during an issue out, whenever you issue out, or whenever a write comes. Because notice there's issue, and then write. Oh yeah, I need to. Issue, reading, instruction. Okay. Here you go.
When you want to get off the darkest ground, the gravity pulls you straight down. Earth from a bird's eye view.
Okay. So if the pending read has, I'm gonna change that text color so it matches a little bit.
When you want to get off the darkest ground, the gravity pulls.
Okay, so if there's a pending read, I actually hate that that's a straight line. It's really annoying me. There we go. I can deal with that so much better. Oh. There we go. Okay, I can deal with that. I think that covers all of the states then. So what I was getting at before I got distracted by filling out the state machine again was, since in order to know, like this, whenever it says 2 run ahead, 2 run ahead, 2 run ahead, 2 run ahead, I need to know that information to make these decisions for this state machine. But if which means I need to check, is the state machine, am I going to actually push the instruction to the run ahead queue? So with that being said, having this, since I need to check it anyway, there's no point in having this here. So which means this needs to be moved.
Oh, interesting.
What?
Oh, just that's same cycle, right?
Yeah, the blue line's a cycle.
Okay. You're gonna be checking there anyway.
Yeah, I gotta check there anyway, so there's no point in shifting it down. Oh my god.
Whoops.
Okay. Now, let me see if that fucks anything else up. So, in this run ahead check, which means this validation does not even need to happen. I don't give a fuck about this at all. This module isn't really even needed. Because the register file itself, well, yeah, I'll take a, no, I don't really even need to, because all I need to do is have a single wire out of the register file that just says, like, output
I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking.
So I'll have to do these. But I'm kind of fine with that.
But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave,
Yeah,
I'ma
so I'll
let
need
you
to
go.
promote to handshake. Oh wait, no, I have the stall wire here, so I don't need a handshake. All I need to do is have... run ahead and queue. Cool. I'm just gonna make a new file for this.
I fell where my demons dwell, my own little nightmare, I call it hell. Oh well, so get back up, climbing,
So
I'm done with this ride, is what I tell myself.
try and go through this design a little bit more smarticle. So I'm gonna make a list of all like the inputs and outputs we need. Required inputs. So the only thing we really give a shit about is pending. Oh yeah, dirty status to go to the run ahead queue. Run ahead queue. Run ahead and queue. I think that's it. Because we don't care. Nothing in the CPU cares if it's clean, except yeah. So on this given thing, the write status, pending write will tell it whether or not it needs to stall at all. The dirty status tells it run ahead queue whether or not it can issue. The run ahead queue and queue tells it whether or not to actually take the instruction, put it the to run ahead queue. So it's here, here, here. Word inputs. A pending read. B pending read. Okay. All we need to do is say, oh yeah, if so we need to know if instructions from the run ahead so we can actually do this decrement. Oh no, A and B, they're the same thing. Because this is just worried about a single register. We don't care whether or not it's A or B. All we care is if it will be written or will be read. And then if it's going to be written, multi-cycle write. Yeah, because the multi-cycle write covers these three. Oh yeah,
Right back.
Huh? In order to implement this, these are the statuses we need. We need to know whether or not it's dirty, whether or not it's to be written. So these two I'm going to mark blue, I guess. Ugh, I don't like that shade of blue. Sorry, just gonna slightly. Okay, and then the inputs will need to be, if the operand's being read, if the operand's being written to, if the instruction is going to the run ahead. Okay, yeah, so we decide if you're going to the run ahead. Okay, I'm kind of happy with this. Just kind of looking over it real quick. You know what, while I remember, I'm actually going to do something real quick. I have not been doing this like I should. Making proper, like, new channels for each development. This is part 15, yeah. Where the hell did that download even go? Oh, it is in there. Why the hell? I'm so confused. Oh well. There we go. I made a post for this, and I uploaded the PNG of the state machine. Even though it's not cropped properly, it kind of makes me sad. I need to re-export it.
Aw.
Oh, never mind. It's just Discord being weird. No, it's not. What the hell? File, export, PNG, crop. Okay, I'll have to create a new post again. Part 15. Registers. Status. There we go. Now it's centered and it doesn't look stupid. Okay. And Bantus.
Yeah, was he doing a diagram like this?
No, if you look at his new CPU thread
Mhm.
in the project help, there's a while ago he posted, and he's linked it like a dozen times, his state machine for his register file. Yeah, here it is.
Yeah, I see it.
Initialize remaining registers. It's available AR, RB valid, RB not valid. But yeah, now we have our register state machine. Let's see how simple we can make this. So I'm going to, let's say, since it has 4 states and each ALM that we're working with in the FPGA is 4, I'm going to make every state its own bit. It also means that I can output to be written in dirty vector just by sampling state bits. Actually, I only need 3 bits. Well, nah. I'll go full 4 bits. And I'll initialize. Do I need to? Yeah, it's gonna make logic easier. 3. I'm failing at this so bad. 3, 4. Okay, so this is... I'll start my normal notes I have. State, name, net, trigger, next. Okay, so then we have the first state being clean, which is going to be 4, 1. Clean, let's go. Clean, dirty, soil.
Name right. Editable?
Okay, then this, I'll do the triggers last. I know, sometimes I feel like I have really efficient keyboard shortcuts and other times I just go so slow with it. So clean can either be 4B001 or 4B. Okay, and then from dirty, you can either be or B. You can go all 4 zeros, or you can go.
What's all zeros? No, nothing there.
Oh. This default should be 4 or
Mm.
5 B 1 0 0 0 1. So that way, no matter if this gets into some unknown state, it's going to immediately trigger itself because the upper bit's the trigger and go to clean.
Mm.
Clean. Dirty. Code. Ending. So so here's the thing I just thought about. In the pipeline, if you have an instruction that's coming through and you're writing to going to pending right at the same cycle that you have a load come back and store, you should just stay dirty and just let that issue. Do I even need? I don't know if I want to care about that. So if you're dirty, you can either be. You have 3 options. Okay, so then this would be, it'd be clean if you so something, then the middle, this bit's always gonna be 0, and then something else and something. So this upper bit will be if you're multi-cycle right. So if you're doing multi-cycle right, so dirty right comes in. Okay, so dirty right, and then this one down. You'd stay dirty if dirty right and dirty issue. Okay, yeah, so this needs to go here if there's no dirty issue. So if you're this LSB, if you're dirty issuing and you're not dirty writing, does that make sense? So you're gonna stay dirty, or no, you're going to go to pending write based on if you're writing, if you're trying to issue a write to a dirty instruction.
Right.
I'm just gonna actually move this. I'm gonna give these names. Dirty right equals dirty issue attempting to issue operation. So if you're attempting to issue on the same cycle you're writing, yeah, that's fine because the forwarding unit will catch that value. So even though you'll have the wrong value on hand here, the next cycle the forwarding unit will catch you, so you're fine. So if you have a dirty issue and a dirty write having the same cycle, that means you need to stay dirty. But if you have a dirty issue when would you go to clean? You go to clean if you're writing dirty and you don't have a dirty issue. Okay, there you go. And if both of these aren't true, then you don't fucking care.
Mm-hmm.
Cool. And soiled can go. Oh, I forgot a transition in the state machine.
Oh, the other way, yeah.
If the pending read clears, then you can go from soiled down. So then for this, you can go to 4B120 or 4B. Okay, I'm gonna back up and do this top one because I kind of skipped it. So this goes to dirty or soiled, which would be 1B0, B0. So this would be a dirty issue. And this would be a
Oh.
Hello.
hello. So, do you see my ping? Venitas?
Sorry, I didn't realize I was muted. Yeah, I saw the ping.
It's very helpful to have this state machine diagram.
Yes, it is. Run hit enable and will be red. Okay.
Right now, I'm going back to the map tables that I wrote up and modifying one of them.
So you go soiled if you have a issue reading instruction. So if you send an instruction to the run ahead and you're reading, Yeah, that works. So if you read, yep. Then if you're to be read and you're pushing an instruction to the run ahead and queue.
I do not.
Okay. If you're issuing a dirty, then you just need to go straight dirty. You need to skip soiled. I want to know, is there actually any situation where you could be dirty and soiled? So if you're marked dirty,
Wait, what are the conditions for being marked dirty and soiled again?
in the state machine,
For being marked what?
Oh,
Okay.
yeah.
Okay.
Um,
so if your operand's dirty and then you try to read from it, you're going to be pushed. What happens if you... I need to go through an instruction sequence real quick. That's whether or not you try to read a dirty value and see how it's... Just to work through my brain to make sure I didn't overlook some circumstance. Okay, so now you have an add R1. So it's marked dirty now. And then if I do a add R3 R1, this gets pushed to run ahead. So then, since that gets pushed to run ahead queue, my question is, if you do a add R4 R1, you do something like this. What happens to these instructions? They have to wait. They have to be pushed to the run ahead queue. But I'm gonna
wait, could you clarify what exactly the difference between dirty and soiled is? Because I don't quite understand it.
So dirty, so since this pipeline is split into two halves, single cycle operations and multi-cycle operations, the dirty bit is whenever you're writing an instruction that just got issued is a multi-cycle operation, so the system knows that that's not a clean operand on the next cycle. So let's say since it's a dirty operand, since the next instruction wants to like use that dirty operand, you take that instruction and you push it to the run ahead queue. However, the B operand on that operation, right? The B operand on the... So, the B operand in this... Or, let me do another... So you have load R1, R2. Then you have a add R1, R3. In this case, this R3 right here becomes soiled. Because if you have another instruction right here that's add R3, R4, this instruction is being blocked by this one because it's a write after read hazard. If I write that the third instruction before the second instruction finishes, then I will corrupt the second instruction. So soiled is a way for my system to realize, oh, there's a pending read on this register. There's a pending read on this register, and I can't write to it.
Oh, okay.
Now there's like let's say, you had add R1 R3, add R3 R.
Wait, so for your assembly syntax, is it operation, source, and destination? And that.
No, it's every single 2-operand in assembly. This first operand, your source and destination, and the second one is destination. So it's A plus equals B, or A equals A plus B.
Oh, okay.
So in this situation, R3 is marked soiled, and then on this operation, you would increase the to be read counter, or the pending read counter, by 1 for R3 gets incremented. And then if something needs, so then if this instruction finally gets to go through, but then you have another instruction here that's clearing the soiled bit is something that I'm thinking about right now. So when the soiled bit needs to be cleared, pending write can go either just soiled or clean. Let's go to okay, this is not pending read, and this is okay.
I think the girls with their nails done
Yeah, so if you're going pending write and you have pending write and you get a multi-cycle write back, that means you clear the you cleared this issue that made it bounce up to here. So now your instruction can come and either mark it dirty again or go through like normal. But because your instruction is coming through, if there's any pending reads still active by the time you get to the head of the queue, then you go soiled, so that way nothing else can write back to that register until those reads have cleared.
Ah, okay. Gotcha.
So, but when you're soiled, the clearing the soiled is the last like question of this whole thing for me. Oh my god. Hold on, I just got a notification. I want to do the math on this real quick. How many? 5,283. Is that how much it was? 5,253. I think my dad has a book problem. 5,253. 5253 divided by 60. 87 hours. Divided by 24. That bitch spent 3.7 days last month reading books on Audible, just listening to books.
What are you talking about?
I got a notification because I share an Audible account with my dad, because there's like 2 books that I've ever gotten. So I got and so I get his notifications. So I got a notification saying, "Wow, you read 5,000. You read like 5,200 minutes. You listened to Audible 5,200 minutes last month." And I was like, "That's a lot of minutes."
bought my mom the Kindle, and she had every free book on Amazon like in the first couple months. pretty
That's
wild.
amazing.
Yeah.
By the way, I'm going to I'm going to end the stream in like 10-15 minutes. Just because I want to get some work stuff done, and at some point they're going to be knocking on my door to come do maintenance, and I don't want to be in the middle of a stream thinking through this stuff and have to like stop what I'm doing.
Fair enough.
So if you're soiled, you're soiled. So what I'm wondering, hold on. So what I want to see is like, if there is a case where an instruction comes in, so you're marked soiled when you have this instruction stream, like this is where you would be marked soiled. You had more instructions come out here. So what I'm wondering is there any time where the pending, you would need to clear the soiled when the pending writes were greater than 0. So if you had this come through, then you had R1 clear. That means this could come through, and your pending reads could then issue. Is there any way? Then how would I? I'm already soiled. What actions make me soiled normally? When you're issuing a reading instruction or issuing a writing instruction. Or no, yeah, okay. When you're already pending write. You have a pending write. You're marked soiled, and you have a bunch of registers stacked up. You have a bunch of things stacked up to use you. You have like all these worked up. All these are in the run ahead because they're all waiting. Then if I were to do like a sub or 3, that would stall. Well, this would be marked to be written and then pushed, so then you could have more. Okay, so then yeah, so you're soiled here. Then either you get to the end of this and nothing happens. And you're then marked, and this instruction happens, and you're marked to be written, because this would be inside the queue. So you'd be promoted from soiled to be written. Since all of these are in. Oh yeah, so I can just I do clear soiled whenever these pending reads clear, because even if, let's say I get here and these instructions are pulled up and they're in the queue, that means the run ahead will be a non-zero value when I finish this to be read instruction, to be written, which means it'll get trapped in the multi-cycle pending multi-cycle write back. Actually, it should be any write back. Shouldn't be multi-cycle, it should be any write back. Because soiled can Yeah, because right now if you have a pending, if you're marked pending write because of this instruction, that subs a single cycle operation. So you'll never need to be dirty, and you won't have a multi-cycle write. So in order for this to actually be cleared, you have to wait until R3 is written, and then once R3 is written to, then these instructions up here would be able to be issued. Yeah. And because they wouldn't have a to be written or a dirty flag, they'd be just streamed right out straight as can be from the run ahead queue in order, because there's no delay hazards between here, and if there what if this is a load? Marked to be written, later to be I'm wondering, so that load, if we come in here and we do this load, it's technically a new operation. So as soon as these pending reads, this would get pushed to the register file. You know what, let's use this a mult, because a multiply isn't a new hazard chain, it's part of the same hazard chain. So then this ends up being marked. Those run and clear as they should. Then these mults get issued. But then my issue is that if these are allowed to issue, hold on. So this goes to the run ahead queue, the mark of to be written. And then these instructions would be behind it. So that means you have to then once this instruction issues, it's going to come down the pipeline with these immediately flowing behind it. Which is a problem, because now you have this instruction that has gone from run ahead, fetched, run ahead, chasing the mult, back to run ahead. That's the issue I'm trying to resolve, because these instructions would come through, and if this chases the mult through the pipeline, then this is going to be like, oh shit, you're waiting on here now, I need to promote these instructions up to the top. So I think the resolution from there would be, if you stall out if you try to read or write a to be written value, would yeah, that would solve it, because I can't issue, if I don't stall on trying to read a to be written value, I have to go push it to the run ahead queue. But you hide your pain, but I can see it etched on your face. I know the feeling, swear you're okay, but you're barely breathing. Don't you walk away. I feel you getting lost, I feel you trailing off. Feel it in your words when you say there's nothing wrong. There's something so subliminal about the way that your hands shake whenever you talk. You stare into space like you're lost in your thoughts, surrounded by your paper walls. Tell me what's been going on. So what this would be, so this would lock up the system then. Load R1, R2, add R1, R3, add R3, R4. This would be soiled, To be written. Okay. I'm happy with that. I'm very happy with that. Either of these would stall. So let's make this. Yeah, I'm fine with that. So in that, if those 4 instructions came through, 2 instructions would be, those 2 adds would then immediately become pending at the front of the run ahead queue waiting, and that sub would be just waiting as well, so the system would stall out. Then it would immediately clear those instructions. But any instructions that weren't, but yeah, you could still issue instructions in between those slots as long as they were not part of those same chains. Or if they had their own chains, then those chains would be interweaved inside the same queue, and that would be fine. So that's the nature of the run ahead queue. It just holds all the collective chains. Yeah. Okay. Cool. So with that being said, I'll make a note. Always stall when wanting to read or write a pending write register. Okay. That works. I think I'm gonna call it here. And then Friday I'll work on implementing this and actually like building out this hardware for it and testing it. I'll write a little test bench for this module and make sure we're all good. Yeah. And now that this is resolved, once we get done with this, we can go back to the stat cache and actually add proper register status systems to that. But since we have a working state diagram that we're happy with now, that should be 10 times easier. Yeah. I'm happy with this.
Progress. Sure.
Hell yeah.
Job.
Coolio, Julio.
Shall the next one.
Yeah. Have a good one. Bye, the no viewers on YouTube right now.
It's me.
It shows 0 because you're muted.
Ah.
I'm watching it too on another screen, but muted, so it shows 0.
Muted. Okay.